Find the points of intersection of the graphs with equation y equals x squared minus x minus 18 and y equals x minus 3 if they exist. So given that we have a quadratic and a linear, it's not necessary that there is a point of intersection, and there might be one or two possible intersections. So let's think about how we could solve this. With these kind of functions, we're going to use substitution. Given that they are both equal to y, we're going to substitute the y in each of them for the x values. So we're looking for the point when x squared minus x minus 18 is equal to x minus 3. This is a quadratic equation, so we can solve it by rearranging it and putting it equal to 0. X squared minus 2x minus 15 is equal to 0, which we can attempt to factorize. Multiply to give minus 15, going to be 3 and 5. And add to give minus 2 means it's going to be minus 5 and plus 3, which means our solutions are when x is equal to 5 and x is equal to negative 3. But we're trying to find the coordinates, not just the x values, so we now need to work out the y values for each of these. We do that by substituting back into either of these equations. The easiest one in this case is the linear one. Y equals x minus 3, so y is equal to 5 minus 3, which is 2. And in this case, y is equal to minus 3, which is minus 6. We have a think about what this looks like. We have got a quadratic here, y equals x squared minus x minus 18, which is going to do something like this. We have got a linear function, x minus 3, which goes something like this. And what we're saying is that the points of intersection, these 2 points here, are at 5, 2, and this point here is at minus 3, minus 6. Just having a think, how could we have determined how many points of intersection there are without solving the actual equation? Without going through this full process, could we have worked out how many solutions we were looking for, how many points of intersection there were going to be? Absolutely. We can use the discriminant, which we saw in the previous skill. We would have to use the discriminant at this stage here. And if we use the discriminant at this stage here, we would find that that is greater than 0. So there are 2 solutions to this quadratic equation, which means there are 2 points of intersection. So we can also use the discriminant in these cases to try and find how many times they're going to intersect.